Welcome to FMA 0116 Mathematics 1 Chapter 2. Okay, this video will be your last chapter for Chapter 2. We are going to discuss absolute value. There are two things in this chapter. The first one will be absolute values. The second one will be absolute inequalities. Okay, first we look at absolute value. Okay, so when we have absolute value of x, actually the formal definition will be what is the distance, okay, from your origin to the right hand side and to the left hand side. Okay, if we look at it, the distance for the right hand side is 3 unit and the left hand side also 3 unit. Okay, so the distance okay, from the 0 to the -3 is 3 unit. Okay, so that's why in absolute value we always having a positive value because it is the distance. Okay, so now, okay, x is just a variable. Okay, sometimes inside the absolute we can have some other thing. Okay, some other expression. For example, this one, our expression is x plus 3. Okay, so according to the formal definition, okay, what is in the expression inside the absolute is the one we're going to get in the positive and the negative for the x greater than 0 and less than 0. So for this example, the expression is x plus 3. So for the expression x plus 3 greater and equals to 0, we're going to have the positive x plus 3. If it is less than 0, the expression is less than 0, so we're going to have negative x plus 3. Okay, but the thing is, we seldom look at the expression in x plus 3 greater than 0. So normally we will shift our plus 3 to the right hand side. So our equation or our function will be changed into x greater than equals to -3. It will be x plus 3. When x less than -3, we're going to have the expression is negative x plus 3. Okay. Now, look at the first example. So when you have when you've been asked to solve absolute value of your x minus 3 equals to 6, so we just follow the expression. The expression x minus 3 will give getting 6, or x minus 3 will getting -6. So we shifted to the right hand side is 9, and we shifted to the right hand side is -3. So our solution is in a set. Okay, the curly bracket indicating is a set, so we're getting -3 and 9. Okay, so the second one will be same. So first thing we need to handle our absolute. So by the definition, the expression will give you one is a positive x plus 6, another one will getting you negative x plus 6. Okay, then you solve for your thing, then you will get your answer. Okay, now, okay, what happens if you have both absolute? Okay, so according to that one, the first thing is we going to have absolute p. Let's say we have absolute p equals to absolute q. Okay, by definition, p will be getting net positive of q. Okay, so we just unchange our absolute first, then the second one we getting is p will be equals to negative absolute q. Okay, now p equals to absolute q, so we can make our definition for absolute q. So our q will give us a positive p and q will give us a negative p. Okay, done. Now, so to make this the second option of this, now, so I shifted my negative here. So what is this thing? It said that absolute q is equals to negative p. Okay, this thing is invalid. Okay, reason is when we have an absolute, okay, it is impossible to get a negative value, so this one is invalid. So we only have the definition when have both sides is in absolute, and this is an equal. So you have only two definition. One is q equals to p, the other one is q equals to negative p, or you can say that p equals to negative q. Choose either one. Okay, so that's why here is this one is my p, so p, this is my q. Okay, by just now we say that P equals to Q, so this is P equals to Q. Then the second one, P equals to negative Q, and then you solve it as normal. Okay, now the next one is when we have how about we have a quadratic absolute? No need to worry. By definition also, this expression is equals to positive 4 and this expression is equals to negative 4. Then you solve it because since it's an equal, so you're going to have a normal quadratic. So when the normal quadratic means that you can use your calculator and you can find the roots of this thing. So you have this answer. Now look at the absolute inequality. Okay, so in absolute inequality, okay, when we have an absolute, just now we said absolute x means that it's the distance from the origin. So when less than 3, it means that is the range is in between 3 and negative 3. Okay, so how we going to rewrite this thing? The value of x is in between negative 3 and 3. So we're going to say x is in between 3 and negative 3. Okay, so generally when you have, we said that absolute x is less than p. So we can define it as x is less in between negative p and p. Okay, how about when we say that our absolute, our distance is greater than p? Okay, so when our distance is greater than p is here. Okay, and remember that how about our negative side? The distance from our 0 to the negative side, which is greater than negative 3, so means is this shaded red color side. Okay, so we have the this and this. How we going to say this one is x greater than 3? This is x less than negative 3. Okay, so generally when we say that x, absolute x greater than p, either you're going to have x greater than p or your x is less than negative p. These two are the formal definition. Okay, now there are some tips for solving the absolute inequality. When you see both sides, okay, so both sides, left hand side and right hand side, consists of the sign of absolute. Your technique will be squaring both sides. Okay, why we are going to squaring both sides? Because absolute is equals to set of x squared. Okay, so this is the definition of our absolute. Okay, so because x squared is always positive, so when you square, this answer will be this value will be always positive. Okay, so and now there is a second thing you need to be alert is the and or. Okay, for this one, originally it is or, so please be alert, this is or. Okay, and when this is the thing is in between, when you try to separate it, you will getting the sign of and. Okay, now take the first example. Okay, by definition, first thing, this is greater. Okay, when I have an absolute p greater than q, by definition is p greater than q or p less than negative q. You just follow exactly what is your p here is 2x minus 1 greater than x plus 2. So you solve it. And don't forget this is an or, put the or back. So and then the right hand side, another one is 2x minus 1 less than negative x plus 2. And you solve it. Then just because this is an or, then there will be no intercepting. So you just keep this thing. Okay, this is called inequalities notation. If you want to write, you can always change it to negative infinity, negative 1 over 3, or union. Okay, or is an union at 1 until infinity. You can choose either way. Okay, now how about this one? This one, this you look at the inequality is less and equal to. So remember p, absolute p, when you less than something, less than q, you will get the in between q and negative q. So what you do is, this is your p and this is your q. So p will be in between of your p and negative, in between your q and negative q. Okay, now since I have two, okay, and each part is consists of x, so what can I do is I separated is the first term and the second term. This one I separated into here. Okay, and Then I separated the second term and the third term into here. Okay, so this one will be at my right hand side the solution. This one will be at my right hand solution. Since this one is in between, okay, when I separated it, I will put an connector here is an and, because they must fulfill both. Okay, so you solve at the linear inequality as normal. So I get x less than 2. And this one is my x is greater than 2.5. 2 over 5. Since there is no other thing, so we just combine it. Okay. There. How about this one? Okay. So you solve an absolute quadratic less than 4. Okay. So first thing before you want to thinking how to solve the quadratic, what you need to do is always use the definition to make your absolute disappear. So what you do is, okay, so remember when you have absolute less than q, absolute p less than q, so your p is in between q and negative q. That is the first step. Okay, and since this is x squared, okay, so as just previous example, this one I separated. Okay, so this one I separated. This one will be going to my left-hand side solution. Then the second term and less than 4 will be going to my right-hand side solution. Okay. And since I have this inequalities, which is in between negative 4 and 4, my connector here is an n. Okay. So now, x squared plus, we look at the left one, x squared plus 2x minus 4 greater than negative 4. Okay. So this negative 4 just shifted to my right hand side. Okay, this one is at your chapter 2.2. Okay, how to solve the inequalities of quadratic. Okay, so then the easiest when you have a normal quadratic, just use the graphical method. That is the fastest. Okay, then you find your critical value, you plot the graph, and since this one is greater than 0, I'm going to take my positive answer. Okay, so for the range, so I get my less than negative 2, x greater than 0. Okay, then now we look at the green color side. Okay, same thing, we use the graphical method. So I have my critical value is negative 4 and 2. Okay, since this one is less than 0, so I'm going to take my negative range. Okay, so negative 4, in between negative 4 and 2. Okay, because of this is an n, so we need to find the intercept between my first answer and my second answer. How we finding the intercept? So we use the number line. Okay, so we look at, we have how many points? We have negative 4, we have negative 2, we have 0 and 2. So we plot all the points we have. Okay, and we plug in our first set of answer, x less than negative 2, x greater than 0, and the second set answer is negative 4 and 2. Okay, this is the purple one. Okay, and then you look at this number line. Where are the intercepts? So the intercept is the one I shaded with red color. Okay, so this is the intercept. So what is this range? This range is in between, my x is in between negative 2 and negative 4. This one is in between, x is in between 0 and 2. And since this is two different set answer is independent, so we put an or inside. Okay, this is the answer. Okay, now we look at another inequalities, which is involving rational. Okay, natural inequalities. Okay, so as is always, first thing we need to be make our absolute disappear first. So by definition, less than. So we're going to have my answer is negative 1 and in between negative 1 and 1. Okay, first thing you have to look at it. Since in any inequalities, we don't want, okay, sorry, in every rational expression, we don't want our denominator become 0. So the first thing we notice, x plus 1 is our denominator. So the first thing is our x cannot be negative 1. Okay, but the thing is we still will use x plus 1 to find our value. Okay, but just as our critical value. Okay, so now as usual, we separated into two parts. The first greater than 1, then the second one is the one less than 1. Okay, my left hand side and my right hand side. Okay, so as usual, in the chapter 2.2, whenever you see rational inequality, you can't do cross product. What you need to do, we just shifted -1 to our right hand side, or our 2x minus 1 over x plus 1 to the left hand side. Okay, so what we can do now, okay, for this example, I shifted my 2x minus 1 to my left hand side, and then I find this common denominator, okay, by cross multiple. Okay, so I solve it. Okay, so now I have a normal rational inequality. So I have -3x and x plus 1. Okay, so remember, you can do in this way. So -1 and then the one is 0. Okay, so we have 3 different regions. The first one greater than 0. Then the second one is in between -1 and 0. Then the third one is less than -1. Remember, just now we already said that our x cannot be -1. That's why this one is not square bracket. This one is a round bracket. Okay. Later, what can you do? Okay. Anything greater than 0, you can choose one number. Let's say I choose 5. In between -1 and 0, I choose 0.5. And less than -1, I can choose -10. Use the -10, plug into -3x. Okay, where this -3x coming from? Looking back your factor. Okay, so I just substitute -10, so I get 30, so it's a positive. Then I use my -10, plug into x plus 1, actually it will be -9, so I get -9. Okay, so this one actually is the conclusion. So positive multiple negative is negative. So the second column we're going to try is using 0.5 multiple with my 3x is negative, negative is a positive, and so on. Okay, then this is my conclusion. Okay, when you look at the conclusion, when this one is less than, what you need to do, we look at our negative sign. Okay, so these two is our answer. Okay, then we look at our second part of the solution. Okay, so it's less than 1, same thing. When you see the rational inequality involving the other side, so you need to move either one to the other side. I just move my 1 to the left hand side. Find the common denominator. Then this is my inequality. Okay, so I still using the number table of sign. Okay, so same as your left hand side, and this is my conclusion. Okay, now since this is less than 0, so that means I'm going to look at the -1. Okay, so the negative side is this one. But since this is the indicator connector is n, so I need to combine my left hand side and my right hand side answer. So the blue color is my left hand side answer. My purple one is my right hand side color. So now n, we find the intercept point is 0 until 2. Okay. And now we look at what if I have the left hand side and right hand side having the absolute value. Okay, so remember, when this is an equal sign, we just say P equals to Q and P equals to -Q. But since this is an inequality, okay, so we don't know what is the absolute of that. And because if you change the negative, it will be changing the sign of the greater and less. So whenever you look at the thing is inequalities of involving and less than or greater than. So what you need to do is you just squaring both sides. Okay, so you just squaring both sides. So x plus 4, how you want to make the absolute sign disappear? So you just squaring both sides, because when squaring both sides, you'll be guaranteed it is a positive answer. So my less than is not going to change. Okay, so you x plus 4 square and 3x minus 6 square. So you just expand this one and you will get a normal quadratic inequality. So just using the graphical method, then you get your answer. That's all. Okay, and this is the some exercise for you.